All right, we're going to move into some examples with that infinitely many or no solution type of answer. So we're going to solve it like we normally would. Make sure both sides are cleaned up, do any distributing you may need to do. So in our first example, this side looks good, 4x plus 6. This side over here, we're going to take care of that distributing. Distribute the 2. Well, actually, I'm going to carry down our 4x plus 6. That was ready to go. 2 times 2x, positive 4x. 2 times a positive 3 is positive 6. Okay, so one thing I want to point out. If you notice, on the left we have a 4x plus 6, and on the right we have a 4x plus 6. Is 4x plus 6 equal to 4x plus 6? Yeah, it is every single time you look at it. This is going to lead us to an infinitely many solutions. This equation is an identity. That was one of our vocab words. But let me show you how algebraically we get there. So we're just going to keep solving. We have variables on both sides of the equation. That has to be our next step. Let's subtract 4x and subtract 4x. So we subtracted 4x on the right to get that to cancel. And then what ends up happening is, oh look, it's canceling on the left side as well. You have no variables left to solve for, and what you do is you just carry down what you have left in the equation. You have a 6 on the left side, your equal sign, and you have a 6 on the right side. So you're going to ask yourself, is 6 equal to 6? If you end up with a true statement when your variables cancel, that means that solutions exist. How many solutions exist? Infinitely many solutions exist. Any number you can think of that you would plug in for x will work out. The left side will equal the right side every single time. You could plug in a 5 for x. You could plug in a negative 352 for x. The left side will always equal the right side. This equation is an identity. All right, so that's what it looks like when you have infinitely many solutions. Let's take a look at our next example. Do we have any cleanup work to do? Oh yeah, we got some distributing. So 2 times 3x is 6x. 2 times positive 4 is positive 8. This right side looks okay. We're just going to carry down the 6x minus 5. So if we look at what we have here, I notice we have a 6x on both sides of the equation, but this is a 6x plus 8, and this is a 6x minus 5. Those are not going to be equal. 6x plus 8 is not equal to 6x minus 5. So right now I know it's not going to be the infinitely many solutions, but let's keep solving and see where this leads us. Again, we would get our variables to the same side, subtract 6x to make it cancel there, and then, oh look, it canceled over there as well. You have no variables left to solve for, so I know this will be an infinitely many solutions or a no solution. So what we do is we carry down what we have left in our equation. 8 equals, and then we have a negative 5 over there. Does 8 equal negative 5? And you'd say, no, it doesn't. 8 does not equal negative 5, so therefore, there is no solution that exists to this equation. You could plug in any number for x, the left side will never equal the right side. All right, that's what our no solution looks like. Let's try one more. Looks a little bit trickier. I see a fraction in there. That'll be fun. I'll go blue with my pen. Okay, so let's clean up the equation first. We're going to distribute on the left. 16 times 4 is 64. 16 times a negative 3 is negative 48m equals. All right, so when we distribute here, it's a positive times a negative, so it's going to be negative. This is a 1m, so you're multiplying with a fraction. So you can do 96 times 1, which is 96, and then you divide by the bottom number. 96 divided by 2 is 48. And then the m will just come on down. All right, 96 times 1 is a positive 96. Let's see if we can predict where this equation is heading. Well, first, I don't have any like terms to combine on the left. I don't have any like terms to combine on the right. What I do notice is there's a negative 48m and a negative 48m. I also notice that this one is adding a 96 to it, and this one is adding a positive 64 to it. I think this is going to be a no solution because the left side does not equal the right side right now. But let's play this out and see how it goes. So get your variables to the same side. That 48m is negative, so we're going to add 48m to both sides. It cancels on both sides. So there's a huge heads up. If we didn't notice the equation above, my variables are gone. It's no solution or infinitely many solutions. Carry down what you have left in your equation. 64 equals 96. Does 64 equal 96? It does not. So that means that we will have a no solution answer. There is no value of x that will ever make this equation true.